Hello and welcome back to another lecture. In this lecture we're going to go ahead and take three problems and we're going to find the internal forces, and then we're going to draw the shear and moment diagram in terms of x. So take a look at the problem. The first problem is going to be really a piece of cake. You could have a chocolate cake or a vanilla cake or carrot cake, my favorite, and that's going to be easy. The second problem, it's going to be a piece of pie, and it's this problem right here. We're going to do the same thing. Then the next problem, we're going to pick it up a notch, put some garlic and onion and hot pepper into it and spice it up and do that problem. So go ahead. Okay, let's get to work. So on the first problem, we have this. The first thing you do when you have a problem like that, you can draw a free body diagram and then calculate the external reaction, and from there you can go ahead and take care of it. All right, so free body diagram. All I did, took this, that's the same as here. I took the uniform distributed load, converted to one load with a concentrated load, and then a pin connection here, which is these two reactions, a roller connection here, one reaction, and I forgot to put the moment, and there is the moment at 150 pound-foot, and there's another one right here, same thing, 150 pound-foot. So now this is our free body diagram. So how do I calculate the reaction if I take a moment about point B? Summation moment about point B is equal to 0, and I'm going to say counterclockwise rotation as our own sign convention. That is positive, so we're going to use that. So I'm going to start from this and look at this. This is a positive already. That's 150. So I got 150 already, and then I'm going to take this going to take a moment about right here. So it's going to be rotating clockwise. This distance is 20 feet. So it's going to rotate clockwise. That means it's going to be negative because we said counterclockwise is positive. So minus AY multiplied by 20. All right. Then I have nothing until I come to this one, and that's 5,000. And that's going to rotate counterclockwise, so it's positive. Plus 5,000 time, and that distance is going to be really centered. It's going to be 10 feet away because center of this rectangular is 10 feet. So now time 10, and then I have nothing. I got this moment, and that moment is basically going counterclockwise is minus 150, and that's equals 0, and I can calculate my AOY comes out to be, or not to be, AOY comes out to be equal 2,500 pound. And if I go ahead and do summation f of y is equal to 0, up is positive. Remember, we always said we have three equilibrium equations: summation of y, summation of x, and summation moment. So in here I have AY came out to 2,500. I have nothing else until I get to 5,000, minus 5,000. And then I have plus by is equal to 0, and therefore by also comes out to 2,500 pound. Summation fx is equal to 0. Going to the right is positive, and there's nothing, so ax comes out to be 0. Perfect. Now we're going to go ahead and take this beam. Let's take this beam and just cut it some location, and we're gonna take the beam and we cut it at point of x. Right here we had this reaction of 2,500, and then let me just go use a different color here. We have the load on top of it. And this load on top of it was 250 pound per foot. Perfect. Down here, because we made a cut, also in here we had, don't forget about the moment, there's 150 pound time foot. And on this side, because we're going to cut it, replace with three forces. Shear force, let's call this Vx, and then we have a Nx, and then we have a moment. We replace them with those. So when you make the cut here, you got to replace them with three, four forces. And here we're just going to use three forces. And those three forces we're going to replace with the shear, normal, and moment. Let's call this Mx, all right? And I think we got everything. So this is the x. However, let me erase this ax up here. It's in my way a little bit. We know that what it is anyway. So let's replace that with a concentrated force. All right. So this whole thing will replace with one force, and that's going to be 250 times x. 250 times x. All right, and this mark is not doing good. So we got 250 times x, and this distance right here is going to be x divided by 2. All right, so we're in business pretty good here. And we're going to go ahead and use basically summation moment and summation f of y to solve this. First, I want to know what my shear is. I'm going to do summation f of y is equal to 0, going up is positive. We have 2,500. We have 2,500. Then I have minus 250x. Then I have minus Vx equals 0. So my Vx comes out minus 250x. And if you remember from old days Carl's algebra, we can say Vx is equal, if we factor 10 out, it be 250 times 10 minus x. So let's find out the moment at x. I'm going to say summation moment at x is equal to 0. It's counterclockwise positive. I'm going to go ahead and I have 150, which is plus, okay. And this is going to take a moment about here. It's going to be minus, because it's going clockwise, 2,500 multiplied times x. And then I'm going to have this one. And that's going to rotate counterclockwise, so it's positive, plus 250x times x divided by 2. And then I have mx. And the mx we said is counterclockwise, so it's plus mx equals 0. And now our mx come out, if you simplify this, minus 150 plus 2,500x plus 250 divided by 2 is 125x squared. And okay, that's going to be negative, that's going to be positive, and that's going to be negative. Equal mx. Or let's simplify it. Mx is equal, I can take 25, they all can factor by 25, so I'm taking 25 out, and this become 100x minus 5x squared and minus 6. Okay, so we look at the shear. The shear that we've calculated came out to be, we can plug in that equation, but keep that equation in mind. So we went up, this came out to 2,500. I'm going to go up 2,500. That is 2,500. And then it comes down, because this is a constant, it's come down as a linear. So down the center will be right here, all right? It's going to come down like kind of like this. And it goes up 2,500. So this is 2,500, this is 2,500. To find out where this point is or where this point is, all I have to do is use this equation. I can find out what's my shear at any point along the x-axis. And the moment is basically where your shear is 0, your moment is going to be maximum, which is right here. And in the moment, remember we said at the beginning, I just look on the screen that moment smile is positive, this is doesn't smile kind of. So this is going to be minus 150. It's going to start with minus 150, and it's going to go up like kind of like this. Come up here and come back to minus 150, and then it's going to go back up. You like to know what is this point right here and what is this right point right here. We know this is down the center, and what is comes out of the center, which is the area of here. We got the equation right there. All you have to do is plug it in. So what is when is the m is equal 0? And there's your quadratic equation. So you can start up and say, okay, 0 is equal. I'm going to say minus, let's write in terms of a quadratic equation. 20, this is 125x squared right here. So 125x squared plus 2500x minus 150 is equal 0. So your x is equal. You have x1 and x2, remember, in quadratic equation, and that should come out to double check my number. Quadratic equation was what? It's on the screen. So using quadratic equation, plug it into Excel. You can put them in the TI-84. You will get these answers, but double check my answer. I think I got it right. So these are two locations here, and your maximum is going to be right here. What is the maximum? Maximum is as a distance of 10. And so max is equal, basically plug in 10 right here, come 12,350, and that's a pound foot. This was a piece of cake. Let's go to the second problem. I'm going to erase this board. Second problem, which is piece of pie, and let's do a free body diagram. I'm just going to do a quick one right here. Coming right here, I have one force here, that's BOY, and then I got two force here, AOY and AX. Then I have this, oh, it's going to be down the center right here, so that's going to be W times 2A, because this is A, that's A, so W, it'll be 2WA. That's it. If we take a moment about point B, summation moment about point B is equal to 0. Counterclockwise is positive. Oh, that's interesting. AY should come out to close to almost 0. Yeah, 0. Anyway, let's do it. So this is going to go ahead and negative. We're going to be minus AY times A, and then we're going to have plus, that's a 0. Can't take a moment at that point. This cannot take a moment at that point. So it's equal to 0. Therefore, my AY comes out to be 0. So this force is equal to 0. And if you do summation F of Y, this one is becoming 2WA. And we're going to have 0 minus 2WA plus BY equals 0. So BY comes out to be 2WA. We're going to cut this. We have two different situations. One is, first is, let's say A is, when X is, let's say 1, not A. That doesn't work right. Let's say 1, two situations. When X is less than or equal A or 0. So what I mean if when X is fall between right here. So we're going to do that. I'm going to take that beam and cut it right between between here. And I'm going to call this distance X. And then we have AY right there, which is equal to 0. So that's a 0. And then I have this distributed load on top of it. Let's do a different color. White is good. And I have this on top of it, and that's a W. I'm going to go ahead and replace it, because I can, I'm going to replace it with V, X, and an X, which is 0 anyway. And then I have a moment. Moment comes out to be or not to be MX. So now I do all my summation fx, summation fy right here. Summation fy is equal 0. Up is positive. I'm going to have 0 minus, we can replace this with 1/4. You remember that, so I don't have to go ahead and go over it like last time. This can be replaced with 1/4, and that's going to be w times x. Alright? So minus 0, that comes 0, then minus wx, and then next one is minus via x equals 0, so via x comes out to be minus wx. And then I'm going to take a moment, summation moment, about that point of x is equal 0. Counterclockwise is positive. Now I'm going to have, that's 0, so that can't take a moment. The next moment is that's right here, that's going to be x divided by 2, that distance from center of this. It's going to be wx it's going to come out positive. Wx times x divided by 2, and that's it, is equal plus mx is equal 0, so your mx comes out to be minus wx squared, that's a 2 right here. So there's my mx. The other situation is 2. See how blue color shows up here. So we have 2 when x is bigger than a and less than is equal to a. So what happens when x is fall in this area? Alright, we're going to go ahead and do the free body diagram again. We're going to cut it right there. We're going to call this distance x. So we're going to cut it in somewhere between here and there. So the cut's going to come from here, but the cut's going to be somewhere around there. And therefore, up right in the middle right here, I'm going to have the reaction which we found out to be or not to be. By we said came out to 2WA. 2WA. AY came out to be 0. That's AY. And then we have the load on top of it. And that's basically W, pound, W, whatever per foot could be, any system, W. So now we're going to go ahead and replace those with shear force, V, N, and M. Okay. And this distance is A. And this distance right here is x. Perfect. Rest of it is easy. Take a summation FOY. Summation FOY is equal to 0. We're going to replace this, this whole thing I'm going to replace with one concentrated load. It's going to be down the center. I don't know what the center of this is, it could be anywhere. Because this is an x, so the center is going to be x divided by 2. So let's just say center is right here. Okay, and that distance right here is x divided by 2. And the magnitude of that's going to be w times x. Okay, keep that in mind. So when I do summation FOY, I'm going to have 0 minus wx, 0 minus wx. Then I have nothing else until the shear itself. Well, no, I have plus the 2WA, plus 2WA. And then minus v is equal to 0, so my v comes out to be. That becomes positive, it's become minus wx plus 2wa, or I can say v is equal to take out w and factor that would become 2a minus x. The next thing we want to do is a summation moment about this point. Is equal to 0, so I'm going to have nothing here. That's going to be 0 times whatever. Then the next one is going to be wx times x divided by 2, and that's going to be positive. and then I have this time, this distance is going to be, if this is an x and that's an a, so that's going to be x minus a. So it's going to be that distance. So it's going to be negative plus 2wa times x minus a. And then we have plus the moment. 2wax and minus 2wa square minus 2wa square minus 2w the shear. So at any point of this beam I can tell you what the shear stress is, because I can use this equations or these equations. Now let's go over here, see if you can do the our work there. These are good one. Take these two. Here it's going to look like, but I draw it first and I'm going to explain later. AY is equal 0. And then we're going to come down at the rate of W per foot, per A, whatever. So that's going to become W times A halfway. So this is a WA, that's a WA. And then the reaction takes out 2 times WA, and it's going to bring it back up here. So that's a WA also. So that's why it becomes 2, brings it up here. And then we're going to come back W times A, bring it back 0. The moment, if this is a negative, that's going to come down negative. That's a positive, that's going to come up positive. It's the area underneath here become right here, and that come out the area of that, so it'll be WA times A, and that's going to be WA squared. The area is going to be WA squared. The area of triangle is 1/2 WA times A, so it become 1/2 WA squared. So this is how it's done. Okay. Now we're going to go to the next problem. Look at this problem now here. The first we're going to do is a free body diagram. I'm going to go ahead and replace them with a bunch of forces. I got one force here, and I got two forces here. If this is a AY, AX, and BY. Then I'm going to replace this one with one force right here, and I'm going to replace the one with one force right there. The distance between this is going to be 6, so that's going to be 3 feet. And distance is going to be 1/3 from here. So 18 divided by 3 is 6. So from here to here is 12 point from that force. And that's the 12, so that's going to be, so the magnitude of this one is going to be 1/2 of 3 times 18. This one's going to be 3 times 6 is 18. So 18, and that's going to be 27, I believe. Now we're going to go ahead and calculate the reaction. I'm going to take a moment about point B. Summation moment about point B is equal 0. Counterclockwise is positive. I'm going to have AY minus AY time 12, 18 and 6 is 24, and then that's going to rotate counterclockwise plus 1/2 of 3 times 18 times 12, and then plus the next one, which is plus 18 times 3 equals 0, and your AY should come out to 15.75 kip. Summation of y is equal 0. I'm going to have 1575 minus 27, I believe that becomes 27, and minus 18 plus by equals 0, and by should come out to 29.25 kip. Let me double check that. situation. One is x is from here within the 18 feet, and the other one x is beyond the 18 feet because the load changes. So now you have a two different situation. As showed in the problem, we have x1 and x2, and we're going to go ahead and treat it that way. First, let's go ahead. First, we're going to go to situation 1, where x is less than equal 18, less than bigger than 0. And the loading on top of it, remember, is like this, right here. And reaction right here came out to be 1575. And this distance is the x1. Then we're going to replace it with a shear force via x, and the x, which is 0 in this case, and mx. And this magnet is going to become, that was what? That was 3 cube per foot. Right here, the 3 cube per foot. And then it's going to be x. I want to know what the slope of this line is here. The slope is rise divided by run. So I got 3 divided by 18. And if I 18, that become 1 over 6, right? So the slope is 1 over 6, and therefore this is going to become 1 over 6 times x divided by 6. That's magnitude. And then the concentrated load for this whole thing right here, we're going to replace them with one load, and we're going to call this load right here, represent this whole thing. It's going to be area of triangle, 1/2 of x, so it's going to be, let's call this x1. So it's going to be 1/2 of x divided by 6 times x. So that become x squared divided by 12. Okay, that means it's going to be 1/3 of x. We got everything we need. And we said this came out to be ax is equal 0. So now I'll go ahead and do summation of x, summation of y. Take a moment. Let's go summation of y. Summation f of y is equal 0. Going up is positive. I got 1575. And then I have minus x squared divided by 12. And then I have minus via x equals 0. So my via x comes out to be 15.75 minus x squared divided by 12. The next thing I'm going to take is a moment, summation moment about point x is equal 0. Counterclockwise is positive. This is going to go ahead and go minus 1575 times x. This one take a positive rotation, is going to be plus x squared divided by 16 times x divided by 3. And then I have plus mx equals 0, so therefore mx is equal minus x cubed divided by 36, 15.75 times x. So that was for a situation when the x falls in from here to here. Now we're going to go to situation number 2. Let's change color. So we're going to say when x is less than or equal 18, less than equal 24. Bring in the beam. I'm going to cut it from this angle, okay? I'm going to come in right here. I'm going to say, okay, this is my beam. And we're going to cut it from this side. And the by came out to be 29.25. And then we're going to cut it right here, and we're going to replace it with a shear force, and a moment, and n doesn't count anyway. So m V. And on top we had this type of a loading. And that is 3 cube per foot. 3 cube per foot, and this. Now this is what we have, but you gotta be careful. This is the x2, but x2, the problem when you look at the x2 start from this end. So you can't say this is the x. That's basically become, you're starting from here. From here to here is 24, so x2 is gonna be somewhere around here. So this will be, this distance is 24 minus x. And that's the 3x, and then that's halfway between. So now if I do a summation f of y is equal 0, going up is positive, I have v minus that is, let me change this magnitude. This magnitude is going to be, that magnitude is going to be right here, 3 times 24 minus x. That's what it is, okay? So now we have that, so v minus 3 times 24 minus x, then plus 29.25, and therefore v comes out to be, this is negative, that's a plus, but this is going to go on the other side, the change is going to change sign. So you do your math, 42.75, double check my number, and then minus 3 times become plus 3x, negative 3x. Double check this. I think I'm right. Yep. So now we're going to do the moment, summation moment about point, that point where we call them, let's say x2 equals 0. And we have v, we're going to go start from here. We're going to have 29 plus 29.25 times 24 minus x. Then we have minus 3 times 24 minus x times 24 minus x divided by 2 plus minus m equals 0. All right, good luck. Go ahead, spend a couple of minutes and do this. I just did it. It comes out to, simplified, it comes out to that. So now we did it on both ways. But here's the point. What is the maximum moment? The maximum moment is where shear is equal 0 in this whole thing. Is it going to be in this segment, or is it going to be in this segment? And if you look at the shear force, for this one came out at 15. This is the shear force here, and that's a moment right here. And this one here also, and this one right here. And make shear is equal 0. So I'm going to say, okay, 15.75 minus x squared divided by 12 is equal 0. So then I'm going to go ahead and say, you know how to do this. X squared divided by 12 is equal 15.75. Take 12 multiplied by that and take a square root, and your x's come out to square root of 189, so it's going to stop 13.74 someplace around here. So that's where your maximum shear is going to be 0. Shear is going to be right here. And these are all the line right here. And then moment is going to be right here. Moment. So okay, we came up 15.75. Then this is see that it's a linear, so it's going to curve down. And we said it's going to become 0 to 189. We calculate that. And then it's going to go straight down and until it get to right here and come back up. Because shear is 0, bending moment is maximum right here. Using the equation, plug it in, and we get these numbers. This is how it's done. I hope you like this. I know kind of was a little bit hard, but that's how it is. I hope you liked it. If you do, please give it a thumbs up.